Hi, welcome back. We are on Unit 11, Day 1. We are representing sample spaces. So far, we've looked at representing tree sample spaces using a tree diagram, an organized list, and a table. Let's look at what happens when our numbers get to be too big, that it's unrealistic to try to make a tree diagram or it's unrealistic to make a table. We're going to use, and we just need to know how many possible outcomes there are, not necessarily what all of them are listed out. We're going to use what's called the fundamental counting principle. The number of all possible outcomes for an experiment can be found by multiplying the number of possible outcomes from each stage or event. So, for example, my packing list, I had 3 suits that I could choose from. I had 2 shirts I could choose from. And then I had 2 here that I could choose from, either wear a tie or not wear a tie. If I do 3 times 2, that's 6. 6 times 2 tells me I have 12 outfits that I could wear. It doesn't necessarily list them out, but it tells me there's 12 options, okay? If I'm choosing between maroon and white, that's 2 options for my shirt. Between black and gray for the pants, that's 2 options. 2 times 2, I had 4 options, okay? So then here, I had 3 options to choose to drink, and then I had 2 options for how I was going to drink it. 3 times 2 is 1, 2, 3, 4, 5, 6. So the fundamental counting principle, just you're multiplying how many options there are, okay? To find out your total possible outcomes. Let's look at this example. The pattern for a certain license plate is 3 letters followed by 3 numbers. The letter O is not used in any of the letters, and the number 0 is not used as any of the numbers. Any other letter or number can be used multiple times. How many license plates can be created with this pattern? Okay, so when I think about my fundamental counting principle, we are going to be having 6 different things we're going to do. Now, imagine a tree diagram where for the first 3, you're breaking each one up into the number of letters you could choose. And there's 26 letters in the alphabet. We're using all of them except 0 or O. So that means I have 25 options for if I was making a tree diagram to put in that first column. The second one, so we're using a letter for the first, 3 letters, 3 numbers. So a letter, that's a high school letter, a letter. Then we're doing a number, and a number. Okay, I wonder why we use NO for number. Anyways, that was just my little ADD moment. All right, so we can repeat, which means I've got 25 options for that first space, right? A, B, C, D, all the way through Z, except for O. Then I can do the same thing for the next one, A, B, C, D, all the way to Z. And then same thing here, because it says you can repeat the letters. Then for my numbers, it's single digits, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9. We're not using O or 0. So that means I have 9 options here, and then 9 options here again, and 9 options here again. This tree diagram would be unrealistic to try to create, okay? But if I just want to know how many license plates can we make that are different, I can multiply 25 times 25 times 25 times 9 times 9 times 9. So 25 times 25 times 25 times 9 times 9 times 9 tells me I can make a lot of license plates. I can make 11,390,625 unique license plates using this pattern. Okay, and that's just where I've got the first 3 are letters and the last 3 are numbers. If I start switching up where my letters and my numbers can go, there's no limit to well, there is a limit, but there's a lot more license plates I can make, right? Let's look at the next one. Here's my exercises. My first example after the main example. All right, we are going to be finding the number of possible outcomes for each situation. Number 1, a room is decorated with 1 choice from each category. So I'm going to choose a paint color. There's 8 options. I'm going to choose a comforter set. There's 6 options. A sheet set, there's 8 options. A throw rug has 5 options. A lamp, I have 3 choices. And for my wall hanging, my pictures or whatever I'm going to put on the wall, I have 5 options. So my fundamental counting principle says I'm going to do 8 times 6 times 8 times 5 times 3 times 5. And I'm just going to double check 8, 6, 8, 5, 3, 5. That is what I put in the calculator. And then I can hit enter. And to decorate this room, there are 28,800 different possible ways to decorate this room. Okay, let's look at the next one. All right, a lunch at Lincoln High School contains one choice from each category. So I'm going to pick a main dish. I have 3 options. A side dish, I have 4 options. A vegetable, 2 options. A salad, 2 options. A salad dressing, there's 3 options. I get a dessert, I can choose from 2. And I get a drink, I can choose from 3. So assuming we are required to pick one out of every single one of these choices, that's going to be 3 times 4 times 2 times 2 times 3 times 2, 4, 3, 2, 2, 3, 2, 4, 3, 4, 2, 2, 3, 2. Oh, there's another 3 times 3. 1, 2, 3, 4, 5, 6, 7. 4, 5, 6, 7. I got them all. When I hit enter, I have 864 different meals I could possibly eat at Lincoln High School. That's a lot of choices. All right, let's look at the next one, number 3. In a catalog of outdoor patio plans, there are 4 types of stone, 3 types of edgers, 5 dining sets, and 6 grills. If Carl plans to order one from each category, how many different backyard patios can he design? So 4 times 3 times 5 times 6. There are 360 different possible outcomes for Carl's backyard. Okay? All right, let's look at the last one, number 4. The drama club is holding tryouts. There are 6 roles in a one-act play. Now, there's 6 roles. That's not one of the choices. So sometimes you have to kind of really read and think. There are 5 people auditioning for the lead female. There are 3 for the lead male. There are 8 for the best friend. 4 people trying out for mom. 2 auditioning for dad. And 3 who want to be the crazy aunt. So there are 6 roles. 1, 2, 3, 4, 5, 6. There's the lead female, the lead male, the best friend, the mom, the dad, and the crazy aunt. 6 parts. We're not multiplying the 6 in here. So 5 times 3 times 8 times 4 times 2 times 3. Just double check. 5, 3, 8, 4, 2, 3. I got them all right. When I hit enter, if I'm the director and I'm casting this play, there are 2,880 different ways I could cast this play, assuming that all of the performers are good performers. Okay? All right, so that is the fundamental counting principle. All you have to do is multiply the number of choices in each event that you're doing for the activity. And then the other thing we did in this lesson is we looked at tree diagrams, tables, and organized lists of possible outcomes in situations. All right, if you have any questions, make sure you're asking during sync time, if you're in person during class, or during your tutoring after sync time, or on Wednesdays and Fridays with Miss Sue. All right, thank you so much for watching.